Okay, so now we're going to talk about some chemical reactions of alcohols. We're going to first focus on how to synthesize an alcohol or preparation of an alcohol. And we already learned that in the alkene chapter. If you remember the addition reaction of adding water across the double bond of an alkene, we ended up creating an alcohol. We put an H on one carbon and OH on the other. So this is the subject of preparation of alcohols, or how do you make an alcohol, or how do you synthesize an alcohol in the lab. You start off with an alkene, you add water, you add an acid catalyst, and you end up with an alcohol. So something like this. Then you add the HOH, acid catalyst, the double bond is broken, and you end up with HOH. Oops, this is like the rest of the molecule this way, rest of the molecule this way. There you go. All right, so you synthesize an alcohol by adding water, HOH, to an alkene. That we already covered before, but we're just putting it here in this chapter since we're dealing with alcohols in this chapter. All right, so what reactions do alcohols undergo? They undergo something called a dehydration reaction. They sometimes put this as an elimination reaction. What are we eliminating? Water. When you say dehydrate, that means you're removing water. Okay. What else do? They will do combustion. Remember, just like with the saturated and unsaturated hydrocarbons, you get a match, you get enough oxygen, you will always produce, the products will always be carbon dioxide and water. And you can also do oxidation reactions. Oxidation, I don't know what, oh, I'm getting emails, I guess that's what all that noise is. Oxidation reactions are reactions with an oxidizing agent. And what you're going to be doing is you're going to be removing hydrogens when you oxidize. Remember in intro chem, we said oxidation is basically the loss of electrons. Well, in organic, you find that with oxidation, it's like also the removal of hydrogen atoms. And you'll see that. And then there's also halogenation reactions. All right, so let's first start off with this. We already covered combustion. It's pretty much the same as with the alkenes and alkanes. Oxygen products are always carbon dioxide and water. So let's focus on the dehydration reactions. All right, so if you have a primary alcohol, there are two things that can happen to a primary alcohol when you dehydrate it. Primary alcohol could either be turned into an alkene or it can be turned into an ether, all right, depending on the temperature of the dehydration. At 180 degrees Celsius, it gets turned into an alkene. At 140 degrees Celsius, it gets turned into an ether. All right, so let me show you how that works. This is with a primary alcohol, guys. So here's my primary alcohol. So this is just ethanol. And you are going to heat it up 180 degrees Celsius. So that little triangle is just like your heat. All right, just want to make sure I have a couple of things here. Yeah, okay. All right, so we're going to remove a molecule of water. So you remove the OH And then you remove an H from the carbon next to the carbon that has the OH attached. It doesn't matter which H you remove. So let's say you take this one. Okay, so now we've got this molecule over here. We got rid of this and this. We have a molecule of water. Notice this carbon needs one more bond. This carbon needs one more bond. What do? They form a double bond. So if you redraw it properly, this is ethene. You've turned ethanol into ethene. This is, they call this intramolecular dehydration. That means within the same molecule. Intramolecular dehydration. So at 180 degrees, a primary alcohol will do intramolecular dehydration. Intra meaning within the same molecule, you're removing an H and an OH. You always remove an H from the carbon that is next to the carbon that has the OH attached. All right. Now the other thing that primary alcohols will do is intermolecular dehydration, and that is at 140 degrees. So let's do the other one. And intermolecular means between two molecules. So intermolecular dehydration. Between two molecules. All right, so I've got the same one again. And I want you to just draw two of them because it's going to, even though normally on any quiz or on the homework in OWL or whatever, they'll only just show one. But if you see that the temperature is 140 degrees Celsius, just automatically draw another one in there. But draw it facing this one. So I'm going to just draw another ethanol. I'm going to have them facing each other. Okay, with the OHs kind of looking towards each other. So I have ethanol and ethanol. With intermolecular dehydration, you have to have the involvement of two molecules, right? And even though they never show you the second molecule, you have to assume it's there. What's going to happen is that you remove an OH from one of the alcohols and then an H from the OH of the other one. So you're taking this away and you're taking this away, all right? Because in intermolecular dehydration of primary alcohols, has to be at 140, you're creating an ether. So when you take this H and this OH away, what are you left with? You are left with this molecule. So see what happens? You got rid of the HOH, which is water. That's your water. And now this oxygen needs the bond, this carbon needs a bond, they bond together. And what is this? Carbon, oxygen, carbon. Remember how I told you guys ethers are an oxygen between two carbons? You've just created an ether. We're going to learn how to name ethers in another video, but I just wanted to show you what the reaction is going to be. So with primary alcohols, at 180 degrees, you form intramolecular dehydration and you create an alkene. You take an OH and then the H from the carbon next to the carbon with the OH. With primary alcohols and 140 degrees Celsius, you have intermolecular dehydration. You're just imagining two alcohols and they are both primary, so it's the same alcohol, exactly the same, and you're taking an OH from one, an H off of the OH from the other, remove it, and you end up with an ether. Okay, good. We are going to do intramolecular dehydrations of secondary alcohols in the next video.